Boyles Law. As previously mentioned, understanding gas laws, calculations and gas mixing is a competency skill that you must gain as a Bell saturation diver and ALST. Gas laws are crucial. You need to understand how gases behave under pressure, how pressure, volume, temperature and solubility all affect the diver's physical body and equipment. Try to understand both the laws and how the equation relates to them. Boyle's law: at a constant temperature, the volume of a given quantity of gas is inversely proportional to its pressure. Formula is P1V1 equals P2V2.
Okay, we're going to talk about Boyle's law as it relates to diving. Okay, the definition of Boyle's law: at a constant temperature, the volume of a given quantity of gas is inversely proportional to its pressure. I'm going to do a demonstration here. We have a balloon, small balloon. We have a syringe. Okay, if I close off the end of the syringe and I squeeze the syringe, as we increase the pressure, the volume decreases. As we decrease the pressure, the volume increases. One more time. Increase the pressure, decrease in volume, decrease the pressure, increase in volume. So that's the demonstration of the effects of Boyle's law. Why do we need to know about Boyle's law? Why? We've got gas spaces in our ears, in our lungs, in our sinuses. For example, if you were to come up and hold your breath and your lungs expanded, you could damage your lungs. Now, remember the definition: at a constant temperature, the volume of a given quantity of gas is inversely proportional to its pressure.
I'm going to say it again. The definition: at a constant temperature, the volume of a given quantity of gas is inversely proportional to its pressure. Take a look at this drawing. Okay, on the right we've got our balloon, and you can see on the left it's 0 meters depth, or on the surface. So the pressure is 1 atmosphere. We're on the surface, so the volume is 1. At 10 meters of depth, or 2 atmospheres absolute, we've got half the volume, and you can see in the balloon has decreased by 50%. At 20 meters, we're at 3 atmospheres absolute, or 1/3 of the volume, and you can see the balloon is now 1/3 of its size. At 30 meters, 4 atmospheres absolute, and the volume is 1/4, or 25% of its original size. Let's do a few calculations so we can better understand this Boyle's law concept. A snorkel diver on the surface has a lung volume of 6 litres. What will his lung volume be at 30 meters? Okay, to find out, let's go back to our combined gas law. In the middle of the drawing, you can see the combined gas law. P1V1 over T1 equals P2V2 over T2. Now, because temperature is not considered in Boyle's law, we can see that we can take T1 and T2 out of the equation and use the upper half of the equation only. Right at the top there, P1V1 equals P2V2. Therefore, we will use exactly that. P1V1 equals P2V2. Here's our question. A snorkel diver on the surface has a lung volume of 6 litres. What will his lung volume be at 30 meters, using our formula P1V1 equals P2V2. We can see that we must isolate V2 by placing P2 under each side. That's a division. Have a look at the drawing. Place P2 under each side of the drawing of the equation. Then P2 can be eliminated from above and below on the right side of the expression. Okay, then we can see that V2 equals P1 V1 over P2. We can swing the drawing around to make it easier to understand. If we do a calculation with P1 is the surface pressure, V1 is the lung volume, P2 is the second pressure in atmospheres absolute, and V2 is the second volume in absolute. Okay, now whenever working with gas laws, all pressure is absolute pressure and all temperature is absolute temperature. And all units used in equations should be in one system of units, either metric or imperial. So our calculation there, P1 V1 over P2 gives us our answer. So that's 1 times 6 divided by 4 gives us 1.5. So that's 1/4 of its original volume. Let's try another one. An inverted open-ended container is at a depth of 22 meters. At this depth, the volume of the container, of the volume of contained air, I should say, is 18.75 meters. What will be the volume of air at depth of 10 meters? Okay, in the left-hand side, in the red, you can see our formula, and you can see V2 equals P1 over V1, sorry, P1 times V1 over P2. We've done this already, so we'll follow that formula through. We get 3.2 atmospheres times 18.75 litres divided by 2 atmospheres absolute. We'll bring that down. That's 60 over 2 gives us 30 litres. So at 10 metres, that becomes 30 litres. What will be the volume of air at the surface? Okay, same calculation again, and we can see that we get 60 litres on the surface.
Okay, we're going to use a Boyles Law example here, and we're going to be solving for initial pressure. Looking up here, we're diving to 70 metres of seawater. Diver needs a minimum of 2 minutes of emergency gas. So he has a breathing rate of 40 litres a minute. Normally it's 35, but in emergency it's 40. We've got a bottom volume of 7 litres. So the ambient pressure at 70 metres is 8 bar, or 8 atmospheres absolute. Okay, step 1, we'll go to Boyles Law. So we want to find P1, the pressure we need in the bottle. Therefore, let V1 equal 7 litres, cylinder volume. P2, 8 bar, atmospheres absolute, 8 atmospheres absolute. V2 is 2 minutes times 40 litres a minute is 80 litres. Okay, there's our formula. We need to divide both sides by V1 to simplify the formula to get something on its own on one side, which will be P1, initial pressure. V1, so we will take those out of the equation, they cancel each other out, and we end up with P1 equals P2 times V2 over V1. You're going to have to practice this if you're not very good at algebra. Okay, substitute values. We've got 8 is atmospheres absolute. We've got 80, which is 2 minutes times 40 is 80 litres, and 7 being the cylinder volume. And that comes to 91.43. Please check that. So the required pressure in a 7 litre bailout is 91 bar. That's the minimum. You will usually have a lot more than that. You might have 150 or even 180 or 200. So you definitely won't be down here. Okay, so I must emphasise you've got to practice your Boyles Law calculations, and before you come on the course, make sure you've got your basics. When you get on the course, you won't be able to start with no knowledge of this stuff. You've done it before. We expect you to come on the course, please, with a basic knowledge. Okay.